Yeah, here in this video, we are going to discuss options like parallelism and Terraform replace, formerly it used to call as a taint, and Terraform drift, how we can do the drift detection, and how we can import an existing Terraform resources to our local environment, and what are the debugging options we have in Terraform. Alright, so basically, as I mentioned in one of the previous video, so Terraform by defaultly do the concurrent operations, but it do as a limit as 10 concurrent operations. It is supported to perform or create hundreds of the resource also, but it do only 10 at a time. If you want to increase that, so we do have a command to increase that. So we can simply give Terraform apply parallelism. Okay, so then we can set up the desired number. So you want to give 20, you want to give 30, it will do, or it will create the resources those many as a set. So for example, if I add count here, and if I add count as 15, so now if I give Terraform apply, is it going to create all the resources at a time? No, I have given Terraform format to get a proper format. Let's see, Terraform apply auto approve. Now if you observe, as I have given 15, you see this, it is actually taking only 10 at a time. So plan 15 to add, but you see here 1 2 3 4 5 6 7 8 9 10 only. Okay, so 10 only it is creating. Once this 10 creation complete, then it will go to the next 5. So of course it is giving some error, that is absolutely fine. So maybe it's because of the limitations I have here in my AWS account. That's absolutely fine. So however, I'm doing this to just to show you how we can increase parallelism. So Terraform apply um, parallelism to, we can make it 15, we can make it 20. So now it is going to create the 20 resources at a time. Okay, so yeah, I'm going to destroy that. Terraform destroy auto approve. So but this way, instead of 10, we can actually do more resources creation at a time parallelly. Okay, all right, so this is one option I want to talk in this video. And the next option is, okay, so the replace option. So earlier we used to call this as a tent. Okay, so basically what this Terraform did, it has replaced. So you earlier we used to use this command Terraform taint and what resource you want to taint. So what actually this taint means? Okay, so let's assume like if a resource let's see, the example, a resource is corrupted, you have to replace that with another resource, and someone did some changes outside of the Terraform. So you want to replace the resources with actual or desired state. So you want to clean, recreate without modifying the code. So or you want to just want to test the taint behavior. Okay, so you can actually use this replace option. So the word itself is mentioning what actually it do, right? Okay, so Terraform will forcefully destroy the existing resources, and it is going to create the resource whenever you are performing next apply, even through there is no configuration changes. Okay, so earlier we used to call this as a taint, and now it become as a replaced. All right, so it's pretty simple. If you want to test the replace, so what I'm going to do, okay, all the existing resources is now deleted. I'm just going to create one new resource now. So Terraform apply auto approve. So now it actually uh, creates an EC2 instance here. Let's assume some modification happened outside of the Terraform, or due to some issues I want to recreate same EC2 instance. Okay, so then what actually I can do here? So firstly we need this the block name. Okay, so let's run the command terraform. You can actually plan and then you can apply. So hyphen replace. Okay, then what is our block? I want to replace this AWS instance, we can give, and the block name Mumbai instance, we can pass that here. So now if I click on enter, it is going to plan it. Okay, so what it is doing, it is going to add one resource and it is going to destroy one resource. Okay, so there is a concept, right? Lifecycle, create before destroy. It is similar, but here it is not going to wait, but it is exactly going to create the resource here. Instead of plan, I'm giving apply, and you can add no auto approve if you really want to. So now you see here, this is the instance. It is going to terminate, and with the same AMI, with same name, same instant type, a new instance is going to create. Okay, you see here it is shutting down, and you can observe the new instance creation is going to happen. So it is destroying. So it just replace, it deletes the old one and it is going to replace the new one. Okay, so right, it is still shutting down. You can see the status here, it's still destroying. Okay, it is now terminated. So yeah, it is starting the creation option. All right, so yeah, this is what the replace option is, and we used to call this as a taint, and now it is replaced with replace. And the next option I'm going to discuss is refresh, but the thing is this refresh option is actually deprecated. Okay, so the reason, right? So basically whenever we are using this refresh command, right, okay, it is going to update the state file based on the AWS environment state. For example, I have an EC2 instance in AWS, and if I run this refresh command, my state file is going to update based on the AWS current settings. So whenever we are refreshing, right, what actually it happens, it look at the current real cloud state, compare it with the Terraform state file, and it is going to update the state file to match with the real infrastructure. Always it is going to look, okay, in AWS is the instance running with T3 medium, is the same value mentioned in the state file, then okay. If it is not, then it is going to just change this as a T3 medium. So now what is the problem? So it is not going to update our actual code. Okay, it is not going to update the TF configuration file, it is just going to update the state file, not actual code. Okay, so and that too without making any actual changes to the cloud resources, right? So so what actually it will do, it overrides your state file with whatever is currently in the cloud. Okay, and from Terraform 1.0 onwards, this is actually deprecated. In place of this, we got something called drift. So this drift is not actually a new feature. It's there from it's there in AWS Cloud Formation as well. So if you observe, I think I don't have any CloudFormation template, but there is an option here under stack options. Okay, we have something called detect drift detections. Okay, identify drift detection kind of options we have. So outside of the template, who actually did the modification? Okay, so out, see if the changes happens by using the Terraform, no issue. Terraform is going to track all the changes, it is going to update the state file. But someone changed your EC2 instance security group rules, someone added a tag or removed a tag, and someone changed an EC2 instance, and someone manually stopped an EC2 instance instead of using Terraform, right? So then what actually we can do? So we can use these commands like a Terraform plan, Terraform apply, and we can identify what actually changes happened. So to simulate this scenario, I actually did this. Okay, so first I'm going to launch an EC2 instance. Okay, so I already have it from the previous template. Okay, so then I'm going to verify. Then I'm going to manually change the instant type in the AWS console. Okay, so then I'll verify whether the TF state file got updated or not. Obviously, it won't update as we did some changes outside of the Terraform. Then I'm going to run this Terraform plan refresh only to see the drift status. So when I apply, when I run this Terraform apply, so it will reconcile or it will restore whatever the changes we have. It is going to pick the changes and all, and it is going to recreate the resources with the changes we have in our code. All right, so let's do this to detect the drift. All right, so this is my instance. Currently it is running with T3 small, and even in our Terraform code as well, it is mentioned as a T3 small. So wantedly, I'm going to stop the instance. So the instance is stopping now. Once instance stop completed, I'll change this configuration. Right, so it's still stopping. Okay, it is now stopped. Instant actions, instant settings, change instant type. So instead of small, I'm giving micro. I'm changing it to micro. So then click on change instant type. So now I did some changes outside of the Terraform and I have started the instance. So now what actually I can do is I can plan a refresh to see the drift changes. So to verify the drift changes, I thought I have added a command here. Yeah, it's here, Terraform plan. Okay, we can run this command, Terraform plan refresh only. So whenever we are running this Terraform plan, okay, so then refresh only. Okay, now you see this, it is refreshing the state and it got identified. See, in AWS, right, whenever we perform stop and start of an EC2 instance, it is going to get a new public IP address, so the new public DNS. Okay, and so it is going to get yeah, so you see here the instance ID not changed, but instant type got changed from T3 small to T3 micro. So the public, as we perform stop and start, so it is able to identify, okay, these all the things actually got changed. So now you want to apply these changes. So what, and also important thing is, if you observe this TF state file, so what configuration it is showing? It is actually showing T3 small, but here in our AWS console, the running instance has T3 micro. So now to reconsole this, what actually we can do? we can run Terraform apply. So when I'm running Terraform apply, hyphen auto approve. So now it is going to reconsole, or like it is going to like um, take it to the actual state or the desired state, the valid state actually. So now it is going to modify. So it is going to modify, and you can see here, um, yeah, T3 micro, the instance is stopping. So we can like detect the drift. Okay, so then you can use this Terraform apply to restore it to the valid state. So technically this is what drift detection we call it as. All right, so is this completed? Now T3 small, and even TF state also is contains T3 small. So both are actually in sync. All right, so this is what we call it as a drift detection. And the next option I'm going to discuss is, okay, if we already have a template or a resource in AWS, we can actually import all that code to our local Terraform. So let's assume someone created an EC2 instance manually. Now you want to track it by using Terraform. Okay, let's assume your organization implemented a standard. Okay, um, that okay, no, from now onwards no one should able to perform or create any resources manually. So then what actually we can do, so we can import the existing resources. We can import the existing resources, and so that we can actually manage it from our Terraform code, right? So now, so to perform this, okay, let me first Terraform destroy auto approve. I'm going to delete the existing resource we have here. So meanwhile, I'm going to launch an EC2 instance manually. So launch instance. Okay, you can give a name. That's not mandatory. I'm going to take Amazon Linux. I'm going to take T3 micro. I'm going to choose an existing key pair, and I'm going to use an existing security group which is open with port number 22, and 8 GB is fine. Then I'm going to launch instance, or let me give a name. Manual instance is the name I have given, then launch instance. Okay, so we do have some other tools. We have some tools like a Farmer 2 or Terraformer to pick an existing resource and generate the Terraform code. That actually I will explain in another video. So for now, I'm sticking to the native AWS option. All right, so now to import this, I'm not going to use existing workspace. I'll do one thing. I'm going to create a new one. I think I already did a test here. I'm going to create a new folder, import test. Right. So let me open that folder. Okay. Under Terraform import test is a folder, then click on open. Right. So now I don't have any file here. I'm going to create a new file, and the file name I'm giving it as a main.tf. Okay. So now firstly, if you want to import something here to local from AWS environment, you should have a resource block. You should have, if it is an EC2 instance, right, you should have like a resource block and resource ID. Okay, so then we can run the plan, we can check the differences. So firstly, this is not a Terraform, I have not initialized this path as a Terraform. So I'm going to give Terraform init. So I have initialized that here, right? So first thing, the regular things are common. Our provider is AWS only, and our region is okay, AP South one. Now, so we have to write this import block. So I'm writing this import block first. Okay. So within this import block, we have to mention to. So to where we want to import this. So we have to define a resource section here. Okay. My resource name is going to be AWS instance, and resource block name is going to be, let's assume this is going to be my instance. To this block I want to import. Okay. So this information we have to give. I want to import my resources to here, and obviously it have to be differentiated with dot. Okay, so AWS instance dot my instance. And what is the ID? Your resource ID. So my resource ID is nothing but the instance ID. Okay, so which one you want to import here? So you have to give that. So is this sufficient? No. Okay, so if you observe our previous resource, we created for this AWS instance, right? AMI is mandatory and instant type is mandatory. Without these two resources, it will fail. Okay, so we can actually give a try. I already tested this. Okay, so Terraform we already did init. Okay, so now we added this provider block, right? So it is going to initialize the actual plugins required for AWS. So that's the reason it is always recommended to add provider block first before running this init command. So now Terraform plan generate config out. So now what is the name you want to give? I want to call this as a ec2.tf. Okay, now when I click on enter, so it is going to plan, but you see here it is expecting instant type. It is also expecting what is that, AMI. Okay, so we have to add that. Okay, so instant type must be or launch template or AMI ID we have to define. So now the regular commands, the AMI is equal to, let me choose the same AMI. Where is that AMI ID? Yeah, it's here. I'm going to give that AMI here, and obviously instance type is, our instant type is T3 micro. Okay, right. So now we are going to import this instance configuration to a file here, ec2.tf. Okay, and yeah, we have given, we already defined a resource block, right? So now let's rerun the same command, terraform plan generate config out ec2.tf. so now you can see here it is actually planned. So now we can just run um, terraform apply. So currently we don't have any tf state file. Now I'm running this command terraform apply. Now you can see here automatically this terraform.tf state file is now created, and that too this tf state file is going to have all the information of our existing instance. Now you can even verify here what is the instance, what is the state, what is the key pair we have assigned to this instance, right? So all the information is now here. So technically we created this resource manually. Now I want to do any change. For example, so the name is gone. Why? Because my template don't have that name, right? So now once this is completed, right? So whatever changes I do here, so that is going to apply. So for a testing purpose, from T3 micro to T3 small want to change, or like there is a easiest option I have. See, we created this instance manually. Now as Terraform is managing it, I want to destroy it by using Terraform. Let's give a try whether Terraform is tracking the resource or not. We can identify. So if Terraform is tracking, it have to terminate. Yes, it is actually terminating the resource. So by these options, we can import an existing Terraform code to our local. All right. So yeah, this is like one way to import the resources, and we do have some additional tools as well to import the resources, like we have farmer 2, we have terraformer, that I'll take you through in another video. All right, so before closing this, I want to cover how we can debug the resource as well. Okay, so in Terraform, generally whenever we are running these commands, right, so things happens in backend. So we want to see sometimes if it is failing, or you want to troubleshoot, you want to identify where actually the issue is happening. So what actually you can do, you can set up the debugging parameters or environment variables. Okay, so enable verbose logs. So if you are giving trace, it is going to give every log it is generating. Debug level logs, info general information, warning just warnings, error. See, the hierarchy is, if I am giving debug, right, it contains info, warning and error. If I am giving trace, right, it contains debug, info, warning and error. So to keep it minimal, most of the times, like if it is failing, we can keep it to warning, we can keep it to error only. But yeah, so we have to set as a environment variable. Okay, so now let's switch back to our regular work directory. Right, so this is our regular Terraform directory. Right, so now what actually I'm going to do, export Terraform log. So the log level, we can set it to debug. Okay, let's see, as this is for testing purpose only, right? So I have set it to tf log debug. So now whenever we are applying, okay, Terraform apply auto approve. So generally when we did this earlier, right, we have not seen all these logs. Okay, this is all things actually happening backend. So if you are aware about AWS commands, right, so generally whenever you are executing any command like AWS space s3 space ls, it is going to just give the output. But if you want to see what actually happening in backend, you can add this hyphen debug argument, so that it is going to display everything. So similar way here, so we have set this up, but again we can do one thing. These all logs I don't want to display here in the terminal. All these logs I want to send it to a file. Okay, so I can give export tf log path. So we can give tf log path. So where do you want to store? I want to store here in this location only, tf logs, and the format is going to be logs, or you can give logs, then click on enter. Now when I'm running same command, so this time it is not going to get all the logs, it is going to give the regular output, but all the logs are going to stored here in this file. You can observe that all the logs are storing here, so that if any support team asking you to share any logs, then you can simply send this file. Okay, so this is how actually we can you know set the uh, debug, or verbose logs, or you can set to trace or a debug. Okay, so how we can unset this? There is a command unset tf log, so that the we have unset whatever we have applied. All right, so then we have one option before closing this video. So we have something called Terraform plan debug. So just like as I mentioned, as the AWS video, in Terraform as well, we have this debug. Okay, we can actually use this debug option to see the detailed debug information. So Terraform plan debug. Yeah, it's not a valid command. Terraform plan. Maybe I need to verify this. Debug output tf plan. Okay, so yeah, all right, so I have to verify on that part, so I'll correct this if it is not available. All right, so I'm stopping this video now. See you again in next video. Thank you. Hope you are learning Terraform from our videos. And if you feel these videos are valuable, don't forget to share with the DevOps learners, and don't forget to subscribe. Thank you.